Hope everyone is fine. Welcome to my channel, Aim Up. In this video, we will discuss about Universal Shift Register, which is very important for your academics. Not only for your academics, it also important for many competitive exams and even most confusing topic. Let me make it clear. Before starting this topic, let me make it clear about the names. What do you mean by universal? In the sense, everything, like all the cases, right? Then what do you mean by shift? Means shifting from one place to other place, right? Here also we'll do the shifting operations like shift right and shift left. And then register. What do you mean by register? You might already know it. What do you mean by register?
తెలీదు గుర్తులేదు మర్చి
It is a combination of a flip-flop. We can store n bits of information with the help of n flip-flops.
Okay. Okay. Yeah.
Here we can see different types of registers. Let us say that if it is in a unidirectional shift register means it can perform a shifting operation only in one direction. We can do either shift right or shift left based on the designing. So by using one device, we can do only one operation that can be the right side or left side based on the designing. So the other type of register is that bidirectional shift register. By using this register, we can shift the data either left side or the right side based on our requirement. And this device is designed in such a way that it can perform the two operations for shifting purpose. And the other one is that universal shift register. By using this device, we can either shift right side or left side, and even we can load the data parallelly, and we can even hold in a data, and we can do all these four possible operations with the help of only one design. Now in this video, we'll try to design this universal shift register.
Okay. Okay.
The basic meaning of this universal shift register is very simple. It can do all the possible operations like shift right, left, and parallel load, and no change. So that is the reason it is called as a universal shift register. Very simple. Now let us try to design a 4-bit universal shift register. To design this 4-bit universal shift register, we need 4D flip-flops.
ఎందుకు
Because to store a 4-bit of data, need a 4 flip-flops. Here I'm assuming a D flip-flop. Here we need to design a universal shift register such that it can perform all the 4 possible operations. But the thing is that here we have only one input. With the help of one input, we can do all the 4 possible operations, right? That is why here we are using a 4 by 1 mux. For each D flip-flop, we are connecting one 4 by 1 mux in such a way that based on a select lines, the particular input will be selected to the D flip-flop, and for that particular input we are doing the particular operation. Very simple. So based on the select lines, it will choose any one of the input, and that output of the marks will be connected to the input of the D flip-flop. This is a basic idea.
समझ रहे हो समझ रहे हो आप समझ रहे हो ना
If you see this select lines, let us segregate it. About this select lines, let us say that that is our assumption. Actually here I'm assuming that this S1 and S0 as 0 0, then I must hold the same data. If I say that 0 1 means we are trying to do the shift right operation. If I say about an 1 0 means I'm doing a shift left operation. If I say about a 1 1 means I'm doing a parallel load operation.
నాకు అర్థం కాలేదు సార్. నెమ్మదిగా అన్నీ అర్థమవుతాయి కానీ దా కూర్చోరా.
Let us consider a shift register. This was a shift register. I'm saying the block of the shift register. Basically, if you take the block of shift register, what are the inputs can be possible? If you see here, there could be a four parallel inputs, but because we are trying to develop a 4-bit universal shift register. For that one, if you want to given a four parallel input means I had to given a that inputs that pins must be there, and then if you want to take an outputs at the same time, then four parallel outputs must be there, right? Let us say that I want to do a shift left operation. It means right side of the D flip flop should be connected to the input. If I try to do the shift right operation means we must give another input to the leftmost flip flop. These are the basically inputs we must give it, and to control this one we must give a select lines. With the help of this select lines only we can do all these operations. And basically for all the flip flops we can give for the clock signal. Based on the clock signals only the state of a flip flop will gets updated, and we can even give a clear signal also. Whenever it is required we can clear it. So this was the basic idea or the block diagram of the universal shift register.
यही नहीं अभी और सुनिए.
Now let us go back again. I'm coming for the mux. In this mux, let us say that I'm giving a 0 0 as a select lines. As we decided that this 0 0 means we are saying that no change. Now we'll try to design the circuit.
चलो भाई देखो अब मैं क्या करता हूँ.
To design this 4-bit universal shift register, basically I'm taking one D flip flop. In this D flip flop, one of the input is there and one output is there. Other than this, we are giving a clock signal for this D flip flop and even clear signal also. I'm taking an active low clear signal over here. Like this D flip flop, I'm taking 4D flip flops. So in this way, I'm taking all the 4D flip flops, and for all the 4D flip flops, I'm connecting a common clock pulse. Why?
చెప్పు.
కంగారెంతురా చెప్తాను కదా.
Why? Because we are designing a synchronous circuit. So in this way, we are giving a common clock signals for all the D flip flops. Let me give a common clear signal also. Now we will try to take a 4 by 1 mux. In the case of a 4 by 1 mux, there could be the four possible inputs and two select lines, and for that only one output. Like this, I had to take four 4 by 1 mux. Right, let us say that I have been taken all the four 4 by 1 marks. And one important thing you must observe that whatever the select lines are there, I had to use the common select lines for all the 4 by 1 marks. Now output of every marks I'm connecting to input of the D flip flop. Like this I'm connecting over here, I'm connecting for the all the marks. After this, I'm just pointing out the outputs of the D flip flops. I'm just giving a name over here like A3 and A2, A1, and then A0. I just given the name outputs as like this, and even we can take an output directly over here. I'm mentioning it as a parallel outputs. Now we will do the operation. Here I assumed that if S1 and S0 is 0, 0 means I'm saying that no change. Here I'm trying to indicate with the black color. It means whenever the select lines are 0, 0 means I must hold the same data. If I say this select lines are 0 and 0, this 4 by 1 mux will select the input of 0. It will select input 0. It means input of D flip-flop is connected to the input 0. So here we must do a circular operation. Whatever the output of D flip-flop is there, that must connect it back to the input side of D flip-flop. We cannot connect directly to the input of D flip-flop. We must take help of 4 by 1 mux. So here the output of D flip-flop should be connected to the input 0 of mux, so that the same data will act like input of D flip-flop. Like this I'm connecting here. Similarly, same connection over here. Just for separation, I'm indicating with the black color lines over here for the 0 0. Very simple. In such a way that whenever I'm giving 0 0, every D flip-flop is holding the same information. If I say the next one, that is 0 1, we are doing the shift right operation. In the case of a shift right operation means the data which is stored in the D flip-flop, this data should be moved to the next one. The data which is stored in this D flip-flop, this data should be moved to the next one. Like this, the data should be shifted towards the right side. So the thing is that I cannot connect output of this D flip-flop to this D flip-flop, input of this D flip-flop directly. I had to take an help of mux. In the case of select lines, I'm choosing that 0, 1. If I say this 0 and 1, it will select input 1. So I must connect output of this D flip-flop to input 1 of the second mux. Right? This way, all the data will be shifted towards right side, like this, like this, like this. But the thing is that in the leftmost D flip-flop, we must give a serial input which is used to shift right side. That is why this one I'm giving a serial input, and the next one I can connect it here directly like this. For separation purpose, I'm showing it with red color symbols. So this was like output, and that was we are connected to the mux, second mux for the input 1. In that way I'm connecting it. So in this way we can transfer the information from this D flip-flop to this one. So this is how we have been completed with the shift right operation also. Now let us take the other one. If I say the select line as 1 0, we can do the shift left operation. In the case of a shift left operation means what is the data which is stored in this D flip-flop, this data should be shifted towards the left side. So output of this D flip-flop should be connected to the input of this D flip-flop. However, that is not possible. So that is why we must connect it to the mux only. But where we need to connect it? It means the select line should be 1 0. If I say this 1 0 means it will select the input 2, right? So it will select the input 2, and moreover we are doing the shift left operation, then right side of the D flip-flop should be connected with the input. In that way, we are giving it a serial input which is used for shift left operation. And then in this case, if I say the 1 0 of the select lines, why? Because we are using the common select lines for all the 4 by 1 mux. So that is why if I say 1 0 means here it will select input 2. It will select input 2 means it must get the data from the previous D flip-flop like this. So output of this D flip-flop cell, let us say from here, it has to be connected to the input 2. So that is why I'm giving a connections like this. For the separate, I'm showing with a green color over here. So similarly, I'm connecting like this one and this one. In this way, I have been shifted towards the left side. So this is how we have been done with the shift left operation also. And the last one is that 1 1, which is parallel load. The moment if I select the select lines as 1 1, it must give an input to all the D flip-flops such that it will directly choose the data from the input. I'm marking here inputs as I3, I2, I1 and I0. I'm marking it as a parallel input. In this way, we can do all the possible operations with the help of only one device by choosing the proper select lines. So hope everyone understood the topics. Like if you don't understood it, just go through this video once again. Definitely it will be cleared. I taken a lot of time to create these animations and these blocks. Let me share an a content like the 4 cases. Just take a screenshot of this one. Whatever the things we have been discussed, that the same things are written in the text format. That's it. Nothing new is there over here. This is the one for 2 cases like 0 0 and 0 1. And if I choose this 1 0 and 1 1, and we can see this one. So just take a screenshot of this one. Hope everyone enjoyed the video. If you really like my content, please do like, share, and subscribe.
खत्म. बाय बाय. टाटा. गुड बाय.